Hi, I'm Alex, and today I'm going to show you how you can get to the bottom of incidents in seconds using Coroot's AI-powered root cause analysis. Incidents can quickly become costly, and time is of the essence when you're trying to solve problems, but sometimes it takes hours of manually routing through telemetry data. Coroot's AI-powered root cause analysis can help. In a couple seconds, it'll show you what went wrong, why, and how to fix it, so that your team can get back to development. Or, if they're on call at 3 a.m., hopefully back to sleep. Coroot uses eBPF, or the Extended Berkeley Packet Filter, to automatically build a map of all your services and their dependencies, internal and external. From there, it's really easy to drill down into logs, traces, profiles, and metrics to get a better understanding of what's going on. You can also define custom SLOs, or service level objectives, and get notified on your team's preferred messaging channel. In addition to customizing SLO so that there's only notifications, say, in case of emergency, Coroot will wait a few minutes before notifying your engineers to ensure that there's actually a consistent problem. No alert fog, no unnecessary noise. Coroot's AI-powered root cause analysis is available to Coroot Enterprise users, but as part of our commitment to make great observability accessible for everyone, we've also made it available for our open source community users. Docs on how to get set up are linked below. AI-powered root cause analysis automatically analyzes an incident whenever a major SLO violation occurs. Then it diagnoses the problem and shows how it can be fixed. So, instead of hunting manually for hours through telemetry to solve these incidents, let's see how Coroot can handle it for us in just a few seconds. First, let's check out an issue on Node 3 that had cascading problems that led all the way to our users at the front end. Instead of spending hours hunting through logs and metrics, we can instantly see what went wrong and the exact commands to fix it. Particularly useful if your head SRE is missing at the time of the incident. You can see that Node 3 has been running at 100% CPU use, which caused delays that had a ripple effect through our services. Queries to the DB main database experienced latency, which led to TCP retransmissions and timeouts in the catalog service, which then impacted response times in the front end. Then, the fix is right there. Drain Node 3, scale down a resource-hungry cron job, and increase resource limits for your database. Creating postmortems also becomes easier, as developers can easily take the troubleshooting tips and steps provided by Coroot and use it to form the basis of a more robust report. For more experienced engineers that want to cross-reference the AI's work, you can click Show More Details for a map of the chain of impact and to see time map graph of anomalies in areas such as CPU usage, query and application latency, TCP retransmissions, and evidence found in traces. Let's see Coroot's AI-powered root cause analysis for another common occurrence. One bad deployment can suddenly break everything. Coroot automatically identified the specific application deployment that caused performance issues. Deploying version 0.5 of the catalog resulted in failed TCP connections from front end to catalog. Easy solution in this case. Roll back to the last previous version to restore connection failures. Then fix the bugs in the new version before deploying. And maybe send it to QA this time. Notice how Coroot can quickly trace an anomaly through all of its affected services, saving developers hours of detective work. In addition to being able to review more context with the Show More Details toggle, Coroot also shows a time map of SLI, or service level indicator violations, in this case occurring in the 99th to 75th percentiles, causing a spike of 233 errors per milliseconds between about 6:30 and 6:56 a.m. And now for an incident I'd like to call Another Department Ruined Your Friday Again. Enterprise organizations often have multiple teams working on observability. It's possible another department might misschedule or initiate a network chaos experiment without communicating that effectively to your team. With no configuration, Coroot can trace an incident affecting a front-end service all the way to its source, which in this case would be the chaos experiment, which occurred in the catalog service that introduced artificial delays between the catalog and DB main database. Database queries timed out with context-cancelled errors, and the catalog service began to give 500 responses, and this led to latency in the front end. Once again, you can easily check the exact commands to copy into your terminal, and your postmortem outline. You can stop the chaos experiment, disable its schedule, and immediately restore connectivity. And there you have it. That's our AI-RCA. To customize the model used by Coroot's AI-powered root cause analysis, you can head to the Settings tab and then choose Anthropic, ChatGPT, or any ChatGPT-compatible API. For any organizations that want Coroot Enterprise for features like single sign-on or role-based access control and capacity planning, but do not want to use AI-RCA, that can be disabled here. Many AI-powered root cause analysis tools are based on things like traces, events, or alerts. They give an incomplete picture and can either return false positives or miss incidents altogether. With eBPF, Coroot's AI-powered RCA is informed by kernel-level insights, which is missing from other AI-powered root cause analysis tools. This data is then collected automatically and fed to a pre-analysis machine learning step that selects for the most relevant findings, optimizing for token usage and efficiency. Then, it's translated into an easily readable discovery using a large language model. Thanks for watching! Check the links below to try Coroot Enterprise for free and see how AI-powered root cause analysis can help you reduce incident resolution time after only a few minutes of setup.